Okay, if you can hear me, clap once. If you can hear me, clap twice. All right, all eyes are on the board. Or if you're in my 7th period, all eyes on your computer. All right, so we're going to go around, and I'm just going to write down equations that you came up with. I'll wait until you're all ready. Pens and pencils down. You're looking at me. Everyone's looking at me now. Okay. So I'm just going to write down the equations you have written, and we're going to try to come to some consensus as a class as to whether the equations work or not. So I'm going to pull this out. Here we go. Where does that come from? Okay. All right, this table, what equation did you guys come up with? Even if you don't think it's right, it's okay. Just give me your equation.
Okay, we said y equals 2x.
Y equals 2x. Okay. This table right here.
Well, we know this is wrong, but
We
got y equals 2, and then x, and then x as the exponent, minus x.
like this?
Yeah.
Okay. Back table.
Y equals 2 to the power of x.
And how did you write the minus 1?
Like the exponent.
In the exponent. Okay. All right. Your table, what did you get? Divided by 2. Okay. How about this table right here?
No, ours is also wrong, but it's y equals x squared minus x.
Okay. So we have a bunch of different equations. We don't know if any of them are correct or not, although I suspect some of you know you're correct. And let's just make the table really quickly. Oh, I guess in this case we have the square number and the pennies. So at square 1 we had 1. Square 2 we had
2.
square 3,
4.
square 4,
8.
square 5,
16.
square 6.
32.
Okay, I'm going to stop there. All right, so let's. How would I figure out if my equation is right? How would I go about figuring that out? Ella?
You plug in one of the x values.
Okay. So let's plug in an x value. I tend to think that multiplying by 1 is easy. What do you think? Yeah. Yeah. Okay. So let's try the first one. So we have 2 times 1 is equal to 2. Did that work?
No.
Okay, so we can cross this out. By the way, what kind of relationship is this? This is linear. And a linear equation will give me a graph that looks like a line. This is clearly not a line. I'm just going to keep going. All right. So then, let's take a look at the second one. What number are we going to plug in for x? 1. Okay, so we have 2 to the first minus 1. 2 to the first is 2. 2 minus 1 is? Okay, so that worked. Let's see if it works again. Let's see if it works again. Let's plug in, let's plug in 4. So we have 2 to the 4th minus 4. 2 to the 4th is 16. 2 times 2 is 8. 4. 2 times 4 is 8. 8 times 2 is 16. So we have 16 minus 4. 16 minus 4 is? Did it work? No. All right, so we can safely cross this one out. So it worked for one of them, but none of the others. All right, let's try this next one. Let's plug in 1. So we have 2 to the first minus 1. 1 minus 1 is? 0. So we have 2 to the 0. 2 to the 0 is equal to? Oh, that worked. Let's see if it works for 4. Let's see if it works for 4. So we have 2 to the 4th minus 1. 4 minus 1 is? 3. So we have 2 to the 3rd. 2 to the 3rd is 2 times 2, which is 4, times 2, which is?
8.
Did that work? We have a winner. This one clearly works. Yes, and now he's claiming credit for it now that we know it works. All right. Let's try this next one. Let's plug in 1 again, see if it works. So we have 2 to the first divided by 2. 2 to the first is 2. This is 2 divided by 2. 2 divided by 2 is? Did it work? Let's try the next one. Let's try 4 again. 2 to the fourth divided by 2. 2 to the fourth is equal to? 16. 16 divided by 2 is? Did it work? This one works also. That means that these two equations are equivalent. That's kind of crazy, isn't it? They don't look the same, but they are equivalent. We'll talk about why they're equivalent in a moment. This next one, let's try it. 1 squared is? 1 times 1 is 1. So we have 1 minus 1. 1 minus 1 is? Did that work? No. So we know this one is not correct either. And that's okay. It's okay to try things out and get them wrong, and that's totally cool. But we have 2 that work. Kind of crazy. All right, so why does it work? Zach?
Because, like you told us yesterday, if you have a negative exponent, you need to put the exponent and the number on as the numerator, and put the base number as the denominator.
Okay, so we need to. So you're saying that we need to do something with this -1 because it's improper to have an answer with a -1, and psi is tuned out because it's like, ugh, that is so improper, right?
Yeah.
And you admitted to tuning out? No, I'm just kidding. All right, so this -1, as Zach said, is a little bit improper. So let's take a look at this. How about this? 2 to the x power times 2 to the -1st, right? So essentially, I applied the base to both parts of that exponent, right? What is 2 to the -1? 2 to the -1. Everyone should get this. We spent like forever. Eliana? 0.5. What's another way of saying 0.5? We want working as a fraction. So 2 to the first is also equal to 1/2. So really, we have 1/2 times 2 to the x power. Multiplying by 1/2 is the same as dividing by 2. But wait! There's more. If you order now for limited time, you can get an extra pair of steak knives. If you notice this, math is the study of patterns. Let's go backwards. Let's say we had square 0. How many pennies would be on square 0? Well, if we're following the pattern, what did we do to 2 to get 1? We multiplied by 1/2. 1 times 1/2 is? No way. The y-intercept shows up in the equation. Whoa! Mind blown! All right. So, tomorrow we're going to figure out if that happens all the time. So right now we have 3 different equations. We have 1 equation, 2 equations, 3 equations that all give us the same table. We have 3 equivalent equations, and tomorrow we'll start taking a look at which equation is the proper way to show an exponential relationship. Now, we still have time. Here are the questions I want you to answer. There are 2 of them. One you can answer quickly and easily, especially now that we have the equation. The other one is a little bit more difficult, and we may have to wait until tomorrow to talk about how to figure this out efficiently. If a chessboard has 64 squares, how many pennies are on the last square? And how much is that in dollars? My last question is, we can figure out easily enough how many pennies are on the 64th square. How many pennies are on the entire board? Figure it out amongst yourselves. Go.